Good morning or afternoon. This is the first section of Chapter 9, Day 1. We actually spent about 3 or 4 days this year on Chapter 9, Section 1. This is Day 1 where we're going to look at Pythagorean theorem, right triangle trig, and solving right triangles. To start out with, one of the things we want to make sure we review is how to use the Pythagorean theorem. If you notice, I have a right triangle here. I have a leg that is 6 units long, and I have another leg that is 6, and the hypotenuse is always across from the right angle. If I'm going to find the length of side C, I take side or A squared plus B squared equals C squared. So I'm at 36 plus 9 equals C squared, which gives me 45 equals C squared. When I express this as a simplified radical, I would get C equals the square root of 45. If I break that apart, it's the square root of 9 times the square root of 5, or 3 times the square root of 5. If I put that into my calculator, I would get approximately 6.7. 7. Over here we have another example of the Pythagorean theorem. We are missing a leg in this case, so we would have b squared plus 5 squared equals 8 squared. If I square those first, I get 25. If I subtract 25 from both sides, I get 39. So b would be the square root of 39, or as a decimal, that would be approximately 6.2. The 3 basic trig functions that we are going to be looking at today are sine, and we can think of this as SOHCAHTOA. We would have sine of an angle. We're going to call that angle theta, which would be opposite over hypotenuse. So if we labeled angle theta down here, here would be opposite, here would be hypotenuse, and then here would be adjacent. Cosine of theta would be adjacent over hypotenuse, and tangent of theta would be opposite over adjacent. So just reminding us how to actually find the angle measures and side lengths of a right triangle. In this case, on question number 9 here, we are finding the measure of this angle. In order to do that, we need to identify the pieces of information that are given. 28 is opposite, 42 is adjacent. This is the hypotenuse. It has no information, so that's not helpful. If we have opposite and adjacent information given, we'd have the tangent of the angle equals opposite, which is 28, over adjacent, which is 42. When we're finding angle measures, we are taking the inverse tangent of both sides. So what we'd actually be doing here is taking the inverse tangent, which is on your calculator, that tan -1 of both sides. And what that does on the left over here is ultimately that just eliminates the x, eliminates the tangent, so you're just left with x. And on the right, you have the inverse tangent of 28 over 42. When we put that into our calculator, we want to make sure that we are doing second function tangent, and it'll open up some parentheses, and we do 28 divided by 42. If we hit enter, we get 33.7, about 33.7 degrees. If we look at number 10 over here, here's our angle. We have an adjacent, and we have the hypotenuse. If we are using adjacent and hypotenuse, that means that we would use cosine. So we're going to have the cosine of our angle is 31 over 34. When we go to take the inverse of both sides, take the inverse cosine. What that does is it gets rid of our cosine, leaves us with x over here, and we have the inverse cosine of 31 over 34. If you put that into your calculator, 31 divided by 34, we get 24.25 degrees. So that's when we're finding angle measures. And then as we keep moving along here, this one is going to be when we're finding a missing side. And we have a 68-degree angle. x is opposite of it. 13 is the hypotenuse. If we are using opposite and hypotenuse, that means we would use the sine of the angle 68 is x over 13. When we cross multiply, we get x equals 13 times the sine of 68. And if you put that into your calculator, again, it's just 13 times the sine of 68. You should get approximately 12.05. So the length of that side is 12.05. If you look at our next one over here, 29, 11 is the hypotenuse. X is adjacent to it. Adjacent and hypotenuse means that we are using cosine. So we would have the cosine of 29 equals x over 11. So we are going to multiply 11 times the cosine of x, or excuse me, times the cosine of 29, and we should get approximately 9.6. Okay. If you're going to solve a right triangle, that means you find all the side lengths and all the angle measures. To find side lengths, the ways that we've talked about so far, is you can use sine, cosine, and tangent, or and that's if you only are given one side and an angle. Or you can use the Pythagorean theorem if you are given two sides. Okay, if you're finding an angle measure, first thing you check is to see if there's two angles that are already given to you, in which case you can just use the triangle sum. They add up to 180 degrees. Or you can use inverse sine, inverse cosine, or inverse tangent. So let's look at this one. First of all, we have a triangle here. We have side B is 15. We only have one side that's given to us, but we have an angle measure. Easy way to find the measure of angle B is it's just triangle sum, where we can say we know that if the triangles all add up to 360 degrees, that angle B has to be 62 degrees because they have to add up to 180. So we know that this one is 62 degrees. If I wanted to find side length A, okay, I have a 28 degree angle. Side A is opposite of it. 15 is adjacent to it, which means I have opposite and adjacent, which is tangent. So I'm going to use the tangent of 28 is A over 15. So I'm going to multiply 15 times the tangent of 28, and I get 7.98. At this point, to find C, you can either use the Pythagorean theorem to find it, where you would have 7.98 squared plus 15 squared equals C squared, or you can go ahead and use trig to find it. If we did that, we would use the cosine of 28 because the cosine is adjacent, which is 15, over side C, which is the hypotenuse. When we do this, when we cross multiply, we are actually, to find C, we're going to take 15 and divide it by the cosine of 28, which would give us 16.99. Okay, and we are going to spend a little bit more time with 45, 45, 90 triangles later in the week, so we're not going to look at those. So if we look, if we have this right triangle here, down on this question down on the bottom, okay, angle C is always the right angle, and angle A is 32 degrees, so we'll call this angle A, and side B, here's angle B, which is the only one left, side B is 10, okay? If I need to find angle B, that's easy, that's just triangle sum. We already have a 32 degree angle, which means angle B is going to be 58 degrees. Okay, so angle B is 58. In order to find side A or side C, we're going to have to use trig. So if I'm going to find side A, I have a 32 degree angle. A is opposite of it. 10 is adjacent to it. So if I have opposite and adjacent, I'm going to use the tangent of 32 equals A over 10. So I'm going to take 10 times the tangent of 32 and I get 6.25. Again, at this point, might be easiest to use the Pythagorean theorem and say 6.25 squared plus 10 squared equals c squared. Or you can go ahead and use trig, in which case you'd use 32, you'd have the cosine of 32, because if we're trying to find c, the cosine of 32, 10 is adjacent to it, and side c is the hypotenuse. So we're actually going to divide 10 divided by the cosine of 32, and we get 11.79. And then we have some story problems that work with this, and just understanding what it's asking. Ultimately, all it's really asking is to find what the length is from A to C. In order to do that, if we look at our diagram that we have here, we have a right triangle. We have a 76-degree angle. From A to C, we can call that x. Okay, so x is opposite, and that 2 miles is tangent to it. So opposite and tangent, or excuse me, opposite and adjacent. The 2 miles is adjacent to it. Opposite and adjacent is going to be tangent. So we would say the tangent of 76 equals x over 2. We're just going to multiply tangent of 76 times 2, and we get approximately 8.02 miles across that canyon. Okay, sometimes when you're using trig, you'll have things that are called angle of elevation and angle of depression. Angle of elevation is just basically if you're standing somewhere on the ground. Angle of elevation is how many degrees it is from the ground up to the point that you're looking at. The angle of depression is just the opposite. If you're looking down, it's that angle from where you're at looking down. So if we have a parasailer attached to a boat with a rope that's 72 feet long, okay, so I have this boat down here. Here's my boat, okay. It's attached to a parasailer with a rope that's 72 feet long. So my rope is 72 feet. Here's my person parasailing up here. That doesn't look like a parasailer. And the angle of elevation is 28 degrees. That's going to make a right angle. It's asking how high above the ground, or how high is the parasailer, which is going to be this distance here. So we'd have opposite and hypotenuse. If we're looking at opposite and hypotenuse, that means we're going to use the sine of 28 is x over 72. If we multiply 72 times the sine of 28, we get 33.8 feet. All right, and we had a packet that we worked on out of this. Homework was not in Big Ideas. We've already gone through the whole packet and submitted it to me, so you should already have that done.